Next, moving on to our next panel discussion on system solution approach to future product creations. Our moderator is Mr. Shrikant Nagaraj, who is a Senior Director of System Solutions Engineering at Renesas Electronics India Private Limited, a subsidiary of Renesas Electronics Corporation. He has over 28 years of experience and a successful track record of strategic, technical, and tactical leadership in various global semiconductor companies. Currently, he is heading all the applications development for MCU 8, 16, 32 BIS divisions, automotive product group and wireless production division at India, and leading global strategic accounts. A proactive, high-achieving manager of designs, development, and implementation of software solutions, and a capable overseer of administration and support for dozens of business applications, yielding seismic improvements in stakeholder satisfaction and operating efficiencies. I request Mr. Shrikant Nagaraj to kindly come over to the stage and introduce the panelists. I request all the panelists also to please come over to the dais.
Thank you very much, ladies and gentlemen. I know it's been a long day. So let me invite my panelist, Mr. Ajay Joshi. He's a PhD from Texas University and an MBA from IIM with decades of experience in embedded processor architecture, and he's from ARM. A second panelist, Mr. Qasim, a very passionate, experienced embedded design engineering leader with many years of experience and expertise on embedded processing. I request Qasim to please come on the stage. And Mr. Pradeep Thakkar has led many engineering teams with semiconductors and also the startups. And he has got a great contribution to the automotive world along with industrial applications. Mr. Pradeep Thakkar from D-Matrix. And last but not the least, the most important figure of IESA as well as our industry, Mr. Sanjeev Keskar, who has been having a leadership role in sales and marketing and has led a lot of multinational companies in semiconductors for corporates for very many years and has been a mentor to a lot of startups in India. I welcome the whole panel for this discussion. Thank you. Can you hear me? All right. So, a brief on how this system solutions has evolved. And I've been in this industry for the last 27 years. To be very honest, other than embedded hardware and software, I know nothing in this world, okay? So to that extent, I've been only spending my time on this. So I think about 25, 26 years back, if you look at any of the systems, it was a standalone system. You do a washing machine, it's just a washing machine. You do a refrigerator, it was just a refrigerator. And things were pretty simple. And as the computers started to get connected, we also looked at the embedded systems getting connected. So the embedded systems always had this option of being controlled when you're near that, or you could also control it remotely. So this is how the complexity started, which also gave the use of user and experience to go and control it remotely. The moment we had some systems connected, then came the security. You didn't want your neighbor to operate your washing machine, right? So you had to have some security where you had to go and apply the machines. Now with this security that comes in, with the connectivity, you also wanted some of the systems to be smart. Now when I mean smart, you take a very simple example of a thermostat. You wanted to get to 25 degrees. If there is a single person, you can look at the AC blowing for X number of time at X speeds. And if there are 10 people in the room, then it will still get you to 25 degrees in the same 5 minutes. So there were a lot of sensing, machine learning, adaptation in this whole embedded processing. Now with all this connectivity and security, the embedded engineers cannot have knowledge across. It built multiple protocols. It built TCP/IP, it built Wi-Fi, it built Zigbee. So it's impossible for an embedded engineer to have expertise in multiple disciplines. So people came together. The system became pretty complex, and the system became, it's become very, very useful, and the kind of human-machine interface became very rich. Gone are the days where you'll be pressing some of the keys and then looking through an LCD display to figure out what your menus are. I think it's a very, very graphics kind of a human-machine interface we have got today. So with all these complexities coming in, I think we have got a great opportunity for making a system solutions which is ready for a product design with a customer. So here we are talking with experts today in this panel to figure out, not only for India, but for the globe, that we do system solutions designs. Every semiconductor company in this world does system solutions design. We make reference designs, we make winning combinations from my company, that is Renesas, and I'm sure Texas, ARM, everybody gives this kind of an ecosystem. We want to really discuss about how this system solutions is going to be effective and how is it going to change for future product development of this world in this decade. So we're going to look at some future over here. And most importantly for India and IESA, I think India has always been a global design house for many companies. You see most of the multinational companies coming into India and setting up large foot of design house. But as a product-ready nation, you don't see a lot of Indian brands selling abroad. You can't go to America, you can't go to Europe and find out some of the TVs or washing machines or any other products saying that, hey, this is my Indian brand, it is manufactured in India, and it is selling in Europe or it's in Americas. So that is what I think we are here to understand what the complexities are and how we can make it happen for the future. So thank you, gentlemen. With that, my first question, I would like to ask Ajay Joshi. He has been an architect on the embedded processor. So can you please tell me, as an architect of the current generation chips, how does your architecture while designing the chip help a system solutions to the customer?
So let me start a little bit by painting a view of how I see the world as a sort of CPU architect. I've spent a good bit of my career doing CPU architecture, CPU performance. So we get to talk a lot to our silicon partners who use our compute IP and put them into their products. We talk a lot to OEM who are building products. And sort of these are the three themes that I currently hear a lot. So the first thing is insatiable desire for compute. We always feel that we have enough compute, but as our partners are trying to get into new market segments, they require huge amount of compute. Even when they are trying to sort of push the limits of their products in the existing markets, they want compute. So one thing is that there is going to be more and more demand for compute. But at the same time, what is happening is that compute needs to come with efficiency, that compute needs to come with security, it needs to come with sort of good validation. So this is a trend that is going to continue. Second is a lot of complexity that our partners face, making decisions on how many CPUs to integrate, what interconnect, what memory. So it's quite clear that as we sort of go towards shrinking geometries, making those decisions is not going to be very easy at all. And it's not going to be the case where we throw some IP and they are able to integrate it together. The third trend that we are seeing more and more is because of the insatiable desire for compute, what our partners really want to do is they want customized silicon. They're saying that, okay, if I take an off-the-shelf solution that's available, it's going to give me suboptimal performance, it's going to give me suboptimal power. So I need to do something custom, but I can't start from scratch. So what this really tells us is that solutions is the approach, but it's not going to be sort of one-size-fits-all solution. So we need to, as a compute provider, we need to identify what's the minimum baseline that we need to provide and then help our partners customize on top of that. So that's sort of where we have landed in terms of we need to provide solutions, but what does the solution really need to contain? So the first part that the solution needs to contain is a lot of standardization. So when I talk about standardization, we are talking about standardization within the architecture itself, so that everybody, whether you're building a really small product that gets into an IoT device or a really very expensive product, high-end compute product, you have some basic standardization. You need standardization where your sort of solutions will just plug and play. The second part that you really need is software. So you have seen that there is been a rich history of architectures, solutions, CPUs, and what really proliferates your solution is the software ecosystem. That if I'm spending a good bit of my time trying to provide solutions to certain problems, it is quite important that I take off-the-shelf software, I spend little time customizing it, and then ship it out. So that is going to be a very important part of the solution that we provide. And the third part that is quite important is some kind of scalability. That it's just not possible to design a separate solution that goes into a very small embedded system and then the same sort of, completely different solution that goes into a server. You need some kind of commonality so that the same solution to a certain extent can scale throughout. So looking at it from a chip design perspective, I do see that, the baseline has moved. Just providing compute is no longer enough. We need to provide solutions. But along with solutions comes a lot of standardization, comes a lot of software ecosystem support, and comes a lot of scalability. So these are sort of three key themes I see from the chip industry as far as pushing solutions is concerned.
Thanks, Ajay. That was very insightful. So the next question is to Kasim, as he was touching upon the software for the embedded solutions. How important do you think is a structured, scalable, modular software that is provided by the, and a software architecture that can be unique or it can be common, as like what Ajay was talking about, for system solutions?
Yeah. Hello, everyone. Good evening. I'll keep this question in a bit generic way so that I can answer for the entire SoC manufacturers in general. So when we say scalability, like as Ajay was mentioning, it is like if I want to classify what exactly the scalability is, like any product manufacturer today, they cannot manufacture one component or one unit or one product and take it into every product segment. So we need a range, low, mid, and high, right? So you cannot sell one same flavor for all three categories of customer base. And you cannot have a separate R&D investment for low, for mid, and for high. So your R&D investment has to be consistent and it has to be as minimal as possible when you scale your product segment from low, mid, high. So the scalability starts from there. Like my product has to be, my product should enter into all three categories. It should reach as many customers as possible and it should serve as many customers as possible, right? So in order to do that, the fundamental thing is the SoC or the silicon that comes out should be modular and scalar and should be scalable. That means, like as Ajay was saying, like by just giving compute, you cannot achieve that. So one is the fundamental SoC or fundamental silicon or the processor that comes out is one part of it, and then there should be scalable factor, like you should have accelerators which can accelerate some pieces of it, right? And then comes the software on top of it. Now, for example, if I have an SoC which gives me a simple camera solution for a doorbell application, like somebody is at the door and he presses the doorbell and it basically detects who and what there, versus you are doing a machine vision which is actually checking for the abnormalities in an industry when things are moving on a belt, right? The complexity is changed when it is a doorbell versus when it is in industrial automation. But the company which is actually developing this camera-based vision analytics is same, right? And you need that solution which is scalable for that company who can build low, mid, high, and also for various different product segments in that particular category. So that means the SoC should be scalable. It should have varied or various components which can give that flexibility to scale. Like I can have a fundamental ARM core plus some fundamental display rendering, and if I want a super graphics and HMI, then I should have a 3D graphics accelerated into the system. Now this is on the hardware side of things. What happens on the software side? When I develop an application and I call an API, and that API actually gives me a screen on display panel. Same application, when I run on an hardware which is having a hardware accelerator for graphics rendering, the image should become smoother. And if you see today, right, like the same app is running in your phone on a 5K or 8K phone versus a phone which is like around 50K or 60K, the app is seamless, right? The same app is running on both the devices, but the experience is different and you feel that experience. So that should go into every product segment, not just limiting to the phone. whether it is a washing machine or it is a refrigerator or it is any panel, any camera interface or any industrial automation, everywhere you should see that scalability. And hardware should have that scalability, software should expose that scalability. So if hardware and software goes together, then you can build products that can cater to all three segments of any product family. So scalability, modularity is very, very important in software and hardware is what I feel.
Thanks, Kazim. That was very insightful with your examples that you gave on the cell phones. And Pradeep, who has been a solution provider in automotive as well as in the industrial space, a very simple, frank question. Do you think the solution that you're getting from the existing semiconductor companies today, do you think you can use them to productize your solution very fast? Or do you think that they're just a proof of concept and you need to really work too much on that solution, or it's too much of a work? Is it really solving your purpose?
Yeah, thank you for the question. Yeah, hi everyone. So mostly if you look at the ecosystem that is developing chips, they're developing for the world, primarily Americas and Europe and Japan and now China. Many solutions that we look for, what I usually call it as an Indian pain point, an Indian price point, that solution doesn't exist in market just to be ready to be used off the shelf in many cases. Because most of the infrastructure, most of the customer preferences, most of the challenges are different for where the focus of innovation is. The target market that most companies are developing solutions for is different than some of the unique conditions here. And hence, we can use some off-the-shelf, simpler products like modems and stuff, we are able to take the off-the-shelf. But if you really look at automotive space, our problems are very different than the rest of the world. And of course, we are part of the rest of the world in the business terminology. But our problems are very different. The solutions that we need here don't exist anywhere else in the most part. And the solutions that we adapt that has existed elsewhere may not necessarily be the right price point. So as a semiconductor startup and as a solution provider in automotive, my struggle was primarily in locating what's available and how does it fit and where all I can fill in the gaps. And I found that I think it would have been much easier to do a solution that is at the chip level and then build it further at the software level, starting right side up. So you focus on the, we have the market, but we don't have the product. So if we recognize the pulse of the market, we identify a product, a solution, and then we develop chip solution and software solution, I think it would be much more cost effective. And it will certainly create intellectual property that we really badly need as our own ownership of the IP down the road.
Thanks, Pradeep. That kind of answers the question where we are with respect to the Indian market. And the question to Mr. Sanjeev Keskar is, why is it important for India to be a product nation than just be a design house of the globe?
Actually, this is one of the most important thing for India today, because when it comes to electronics, our consumption story is very strong. With 1.42 billion population, 400 million plus middle class population, everyone is buying smartphones, laptops, tablets, and all sort of electronic gadgets. Last year, as per the report of Ministry of Electronics and IT, our consumption of electronics in India was $120 billion. And as per the same report, this is expected to grow to $300 billion by 26-27. Now, in that $300 billion, $120 billion is expected to be exports from India. But still, $200 billion also will be a very big number. Now, what's happening that today, if you look at the value addition in this electronics, it is only 15%. Okay, that means in $120 billion, $40 billion is finished good import, $80 billion is manufactured in India. But that $80 billion is at 15% value addition. That means ground reality is we are recognizing only $12 billion in a $120 billion market. All others are going as imports. Means government has launched so many PLI schemes. But what's happening that we are getting CKD kits from the global suppliers and we are doing only EMS assembly. So ultimately the local value addition in EMS is hardly 10%. And still 90% worth of components come in a CKD form. And morning also, Mr. Krishnan, Secretary of Ministry of Electronics, was talking about the critical need of improving the value addition. If you look at prior to 1996, India was truly a product nation. We used to have Videocon, Onida, BPL as a consumer brands. We used to have HCL, Wipro, Zenith as a laptop and desktop brands. Entire wireline telecom revolution was on C-dot technology. But when we signed WTO agreement, International Trade Agreement 1 in 1996, we allowed finished good import at zero duty. And post that, consumer electronics was dominated by Samsung, LG, Sony. Your laptop desktop was Dell, HP, Acer, and entire wireless revolution of CDMA, GSM was by Alcatel, Lucent, Ericsson, Nokia, and Huawei. So Indian hardware industry got a huge setback. And now government has launched this production link incentive scheme, PLI scheme, which is definitely helping manufacturing growth. So many EMS lines have set up in last 4 years, or so many global EMS companies like Flextronic, Foxconn, they have set up their shops in India, but we are getting only the low value add manufacturing. So how to improve value addition? On one hand, semiconductor policy has been announced, so component ecosystem will evolve. But another critical need, because India has talent, so unless we do product innovation, unless we make India as a product nation, that is going to really give you value into IP and technology. And that is a critical need of the hour, that we should create innovation from India, we should create product innovation. And for that, looking at the complexity in embedded electronics, the system solution support from the semiconductor manufacturer to enable the startups, to enable the MSMEs to complete their product innovation at a global standard where they can qualify and certify to the global level, that has become a more critical need. So I think the product innovation and product creation is the most important challenge if we have to improve our value addition in electronics.
Thanks, Sanjeev. That has answered most of the questions. Now to Ajay, going back, as an IP provider, how do you view your role in enabling solutions-led product design?
Let me sort of take a step back a little bit. And I think one of the things that has come out of this discussion is we need to make it easy to build products on top of the solutions that semiconductors companies like us really provide. But as I said in the beginning, that whether you're designing a phone, whether you're designing a car, whether that same sort of semiconductor goes into an aeroplane, the basic expectations are same, around functionality, no bugs, security. You want to push last mile of performance. You want to have power efficiency. So it is not going to be possible for each particular product designer to start keeping or providing those kind of features by themselves into the product. So what this it behooves upon us is that you need to start fundamentally building this into your solutions. And a company such as ARM, where we design the architecture, we are in some sense right in the beginning of the cycle, but still have the advantage of seeing which direction is technology proceeding. So I'll outline a few examples on the things that tend to happen to make sure that we are creating solutions. They are actually ready to build products. So an example is security. So earlier it was assumed that, okay, you build products and then you start thinking about security that you want to provide to the product, but that's no longer the case. You may be designing a very, very small product, something like maybe a fish feeder in your tank, or you may be putting that same IP into your car. Security needs to be built in. So a few of the initiatives that are driving really the architecture is how do you make your hardware fundamentally secure through the architecture? So there have been solutions such as having something like confidential compute, which is completely built into your architecture, so that whoever licenses your architecture, the solutions that you provide, you get some basic level of security always through the architecture. So that is a sort of an example of the role I see companies like ARM playing to make sure that we are providing solutions to build products. The other is there's a lot of talk about AI, ChatGPT, and it's quite clear that you'll need some specialized compute, you'll need some specialized IP to do that. But again, you're going to probably take some off-the-shelf solution and then start providing these kind of capabilities. So you want to make sure that some basic AI runs well on solutions. So one of the things that the solution that ARM provide also contains is we make sure that yes, basic AI and ML works well on the compute. You may or may not have an accelerator, but we make sure that through the architecture, through our compute design, we are providing basic level of performance that you may need to provide AI and ML service on any device that you pick up. Whether it's a high-end device, then you may have an accelerator. So again, the solution is, needs to provide some basic AI, ML capability. The other example of this is some of the solutions that ARM provides, which we call compute subsystems. They come with basic features such as that, yes, even if you take off-the-shelf solution, you have the software stack that does basic keyword recognition. So building a product on top of it, it becomes completely sort of easy. You don't have to start building those solutions on top of it. So the key aspect that I'm trying to highlight is building some of these capabilities into the architecture is quite important. The other aspect that I mentioned is software. And software is not just about providing some reference stack or providing simulators for software vendors to bring up software early. But can we provide high quality tested software that you can slap together, it just works on the solution and start shipping products? So there is a lot of investment in these kind of technologies. So although ARM being a hardware company, a significant portion of our company is comprised of software engineers because in absence of a good software ecosystem, your compute systems do not go far at all. And the scalability aspect that I really mentioned, so I think it was also touched upon, is we cannot afford to do solutions for separate markets. We have to find a common denominator and then see what kind of SKUs that we can produce from it. We can't have a separate swim lane for every market that we are targeting. So there's a lot of sort of technology investment in making sure, okay, what is that exact common denominator and what more do I need to do? So to give an example, a basic CPU that is designed may have some add-ons in it so that it passes the certification that it requires to have functional safety to get into certain automotive markets. So again, it's layers of solutions that we are trying to build and a lot of sort of technology investment to make that happen.
Yeah, thanks, Ajay. Now, you just touched upon the software, and that brings up a very nice question. So the question to Qasim is, do you think the software from the chip companies, like the semiconductor companies, I mean, most of the companies do provide, along with their hardware, some software, some stacks and stuff like that. Do you think it's just a proof of concept or production ready? I mean, can we take those softwares and just get into production, or today it's not there? And if it is not there, what are your suggestions on a software ecosystem that should be available for India to make it ready for, products?
Yeah, this is an interesting question, right? And I can split this question into two things. Like when it comes to products and solutions, like the software that any semiconductor SoC manufacturer provides, like what is this software giving an end manufacturer or end product design house, right? So there are two aspects. I want to go back to Sanjeev where he was explaining about the innovation aspect. So the software that comes out of any SoC manufacturer should cater to two things. One, it should enable innovation, and second, it should help in going to market faster. That means the software that is coming out of SoC manufacturer should be ready to use, deploy in the end product. So first question, is the software that is given is enabling innovation? Definitely it is enabling innovation. Therefore, you are seeing so many automotive today, the way the cars are, with the way the radar system included, the way you are seeing IVI, the way you are seeing the ADAS and things where the automotive segment is going versus the consumer electronics, and you get into the white goods and you get into the industrial automation, robotics, machine vision. Everywhere you go, the products that are built are based on the software that came out as the fundamental thing from an SoC manufacturer. That acts as the foundation piece, and on top of it, the product developing house works on the application layer of it. That enables innovation, right? And the second part, definitely lot of validation. As Ajay pointed out, in every semiconductor company today, the large chunk of investment and R&D goes on the software development, and majority of that goes on validation and quality of software that we want to put out. You can see even in Linux open source today, there is LKFT which actually publishes test results. Like after they go and like before they make a release of software, tons of tests gets run on that software, and those results are published in public domain so that anybody can see. Even for TI, for many other companies, the CI/CD of it, the test results, everything is made public to give a confidence, to raise the confidence level in the production companies to pick the software as is, put it in their end product, and take it to the next level. I think the software maturity is there, and the foundation software that is coming out of from all these SoC manufacturers are stable enough for you to get into production, and they also enable innovation. I think these are the few key aspects which I want to bring here.
Thanks for clarifying that, Kasim. I think most of the semiconductor manufacturers are investing, and they have invested in the past to go and give a steady software framework to most of the customers. And thanks for reinforcing that and ensuring that the investment continues to ensure that we are able to make very good softwares. Now, the point to Pradeep is, you have always served the automotive industry too. So, in India, we are lagging behind on the EV and autonomous vehicle. Okay, India is lagging behind on the ADAS system and connected cars and all that stuff. So how do you think, where are we and how are we going to respond to this kind of a development as a country?
Yeah, that sounds good. So actually, I've been wondering where we were actually much farther ahead on the story of the EV. And I'm still to this day, I'm wondering where we lost the plot. In 1996, Bangalore was the hub of design, indigenous design and manufacturing of electrical vehicle. That was all electric vehicle, no hybrid. It was popularly known as Reva. And I'm a Reva owner for last 16 years. That's the only vehicle I've driven. It's beautiful vehicle. Other than battery, I have not had to worry about anything. Now, if we could do this 25 years ago, and Reva was exported to 26 countries in the world. In UK, it was also known as GViz, and it was very popular, right? So if we could do this 25 years ago, why are we struggling now, right? And that's a question I don't get it. We have much richer ecosystem. We have much better government incentives. We have much better skill domains than 20 years ago in our ecosystem on system, product, and technology, right? So I think it is just, I think the gap is again to just ignite the spirit of entrepreneurship and who is willing to step forward. Now, of course, Mahindra, Tata, many other companies have successfully launched EVs since then. And autonomous vehicle, I think, is a great opportunity for India because whatever works in Western countries is not going to work in our infrastructure. Mostly it will work on highways, but not certainly in the city roads. And that's an opportunity for us to solve many very interesting engineering problems that can also be relevant for many other countries with similar infrastructure as ours. And almost a third of the population of the world lives in the infrastructure that is similar to ours. So I think for Indian entrepreneur and Indian technologists, autonomous vehicle is a great opportunity to take the lead. And if we could do EV 25 years back, I'm sure we can do AV now and forward. So thank you.
Thanks for the motivation and encouragement for the country's entrepreneurship. I would like to ask the final question to Mr. Sanjeev Keskar that he has been a guide and mentor to a lot of startups and SMEs on electronic product designs in India. So what are the hardships that they face in today's scenario? And what do you think we as an ecosystem, the semiconductor manufacturers and the system integrators should address it for them?
See, we have more than 5,000 startups working in embedded electronics, IoT, AI space. But if you look at success rate of this startup, it is less than 10%. So how we can improve the success rate of this startup? Because they are doing product innovation, they are creating IP technology. And the critical need of the hour is how we can recognize value addition by improving the local innovation and local product creation. So basic challenges what these startups are facing is particularly when they are at a design level, they need a good technical mentoring to decide what is the platform which will make them techno-commercially successful. They decide on some platform and then after investing 1 or 2 years, they realize that either they are not competitive in the market or they are not meeting with the market's specifications or expectation. So at the design stage, if they get a proper advice and technical mentoring, what will be the right solution to make them successful in that product innovation? That is a critical need. And that is one of the main reasons why startup fails. Second reason is they need a good handholding for go-to-market strategy with the customer connect and to really have a right distribution channel. That is another thing, there should be some mentoring and handholding to happen. And third is definitely the EMS ecosystem and manufacturing ecosystem connect, because these startups and these MSMEs, they don't have their own SMT lines. They are depending on some EMS suppliers. So we need to have a good component supply ecosystem, because the big distributors like Arrow, Avnet, Future, they don't deal with startups and MSMEs. And if these startup and MSME buy from the online distributor like DigiKey, Moser, Element 14, then their cost goes up by 2x or 3x. And then they become non-competitive. So having a local component ecosystem, having a good technical mentoring, and good support for market connect, these are the three critical needs by which we can improve the success rate of startups, and that's where the India can emerge as a product nation. Thank you.
Thanks, Sanjeev. We can, as a panel, take one or two questions from the audience, if you have any, please.
On the SMEs that are indigenous and technical guidance that you mentioned now, is there a collaboration model between universities and SMEs on IP creation and commercialization of the IPs?
Take that question.
Yeah, most of the universities today have the incubation center, center of excellences, and they have industry partnerships also. So I have seen so many incubation centers have already set up in a prominent engineering institute in Bangalore alone, in PECIT, in RV, and in BMS engineering. I have seen good incubation center in collaboration with the industry associates. So I think that is happening definitely.
Thank you. I think we are running the time.
Export control, sorry. Export control also on the IP.
We can certainly take the questions of this. Yeah. Thank you very much.
Thank you, everyone. May I request Mr. Sudhir Nayak, EC member IESA, to kindly give away the mementos. And we can give some claps.